Good afternoon, everybody, and welcome to today's webinar on optimizing productivity and profitability with waterjet cutting, sponsored by JetEdge Waterjet Systems and hosted by Metal Forming Magazine. My name is Brad Kuvan. I'm the editor of Metal Forming Magazine, and I am pleased to serve as your moderator today. Since today's GoToMeeting session is being recorded for archiving, all participants are in listen-only mode. The speaker and other listeners will not be able to hear any audio from your site during the program. However, you do have the ability to communicate with us throughout the program by submitting any questions you might have for our speaker using the question box in the right-hand control panel on your screen. Simply type your question to an organizer as selected from the drop-down menu, and we'll take your questions at the end of the presentation. Also want to let everybody know before we get started that a link to the recorded webinar will be available within the next few days on the websites of JetEdge and Metal Forming Magazine, and we'll send everybody an email with that link so that you can watch the program again or perhaps share it with your coworkers. So now we'll go ahead and begin today's webinar. Joining us today as our presenter is Waterjet industry veteran and JetEdge regional manager Jeff Schibley. Jeff's going to discuss for us how to select the right waterjet pump for your application, cutting with multiple heads to multiply productivity, the benefits of 5-axis and taper-free cutting, selecting the right garnet and orifices for improved edge quality and increased cutting speed, how to lower operating costs, and the importance of proper maintenance to prevent costly downtime. He'll also share case study examples of how shops have successfully incorporated the waterjet process efficiently and cost-effectively. Please welcome Jeff Schibley.
Good afternoon. JetEdge would like to thank you for your interest in ultra-high pressure waterjet technology. I have been involved in the waterjet technology since 1985. JetEdge is a global leader in waterjet technology. We're one of the few vertically integrated manufacturers of the waterjet technology, the waterjet pumps, systems, that type of thing. We're headquartered in St. Michael, Minnesota. We're a privately held corporation, a subsidiary of TC American Monorail. We have a 100,000 square foot manufacturing facility, and we have U.S. regional sales offices in Atlanta, Boston, Midwest, and also our headquarters here in St. Michael's, Minnesota. We also have international office and distributors throughout the world. In particular, we have an office in Shanghai, China. We have distribution in Asia, Pacific, Middle East, Europe, and North and South America. JetEdge manufactures a variety of products and services. We have precision cutting systems, we have portable cutting systems, we have surface preparation systems, waterjet pumps, of course parts, and custom engineered and OEM integrated integration. JetEdge Waterjet Systems, we manufacture positioning systems, and this is what we consider part of our precision product line. Those systems range in size from anywhere from 30 inch by 30 inch to 30 feet by 100 feet. And we, of course, manufacture a lot of different products or gantries for positioning nozzles over those lengths and distances. In addition, we work with integrators for the integration of articulated arm robots and providing our high-pressure technology to them for systems integration for many straight water applications and applications requiring 5-axis of articulation. In our pump product line, we have pumps that range in horsepower from anywhere from 30 horsepower to 280 horsepower. We also build families of pumps within each of those. We have a 36,000 PSI series of pumps. We have 42,000 PSI series of pumps. We have our 60,000 PSI series of pumps. Then we also manufacture the new extreme pumps. They're capable of 90,000 PSI. Each of these pumps are capable of producing ultra-high pressure water. Water in itself has a tremendous power. Look at how the Grand Canyon was created. I mean, it was tremendous volumes of water that erode away the rock and the surfaces there. In the case of ultra-high pressure water, we direct that, and we direct that through a number of items that we call accessories. So we have accessories that allow us to focus that water stream and direct it to cut different materials, or we focus that water stream and we direct it to surface preparation applications where we may bombard a surface and remove paint and other unwanted scale materials from them. So we work with a wide variety of applications. We service, water jets are just used everywhere. People just don't realize how much of the products they utilize in their daily lives are actually produced with ultra-high pressure water. You look around at machine shops and fabricators, well, they'll utilize Waterjet to process materials that won't process well with traditional machining, or that are tough to process with traditional machining. One of those benefits to the abrasive Waterjet in processing metals is the fact that we leave absolutely no heat affected zone. And there is almost no metal that we can't process with the abrasive Waterjet. You look at the automotive industry, which is serviced highly by articulated arm robots, and in particular, look around the inside of your car, your door panel, your headliner, your carpet. All of those items are trimmed with ultra-high pressure water. And ultra-high pressure water got its start in these industries simply as a method to relieve the worker pain that was being created by manually trimming out these openings. So we went in and with the utilization of an articulated arm robot, we can make that water follow a tremendous path, and then a very hair-like stream of water escapes from our on-off valve and allows us to shear carpet, vinyl, foam, and also fabric materials. You look in the aerospace industry, and we're cutting a lot of the carbon fibers, and many of these carbon fibers are bonded to titanium roots or other specialty alloys, and we can process all of those materials in a stack with the abrasive Waterjet process. You look at metal service centers, and many metal service centers are beginning to add abrasive Waterjet, and not necessarily to compete against the job shops and the metal fabricators that are out there, but to allow them to supply near-net shaped parts to their customers who may not have enough volume to utilize or own their own Waterjet cutting system. So with that, now the customer is simply buying a blank tailored to his actual application. We look at OEM integrators, and we work with food processing companies. Ultra-high pressure can actually be utilized as a component to a cold food processing process. Basically, we utilize our pumps to generate ultra-high pressure water. That water is then fed into a pressure vessel that contains packaged foods, and we can now do cold food pasteurization without affecting the taste and the nutritional value of those products. We supply OEM pumps to companies that do material removal. So in many instances, such as jet engine components. They have a coating of they have a coating of a plasma spray coating that's there to protect against wear. So with the ultra-high pressure, we can go in and we can erode those wear surfaces away from the base material without doing any damage to the base material, and therefore allow for repairs to be conducted on worn components and bring them back to life. Expensive components. In many instances, the raw component that's being loaded to one of our integrator stripping cells may have a value of $50,000 to start with. So we also supply to, as I mentioned before, integrators who service the automotive industry. Stone and tile are great applications for abrasive water jet. When you look at the water jet process, and people go, well, how does water cut metals, or how does water cut stone or tile, or many of these hard products? And to be honest with you, it really doesn't. You know, we kind of utilize that terminology loosely, but really what we're doing is we're taking that ultra-high pressure water that we have compressed and held in a pressure vessel, and when we allow it to escape, it escapes through a fine focusing orifice. That focusing orifice is what determines the volume of water that's going to escape, and the pressure that's being applied to it determines how fast that water is going to escape. So we're cutting hard metallics and stone and products like that. We actually come in and we induce, or we allow, the high pressure water escaping from our head to create a venturi or a vacuum, and we draw abrasive into that water stream. Now, all of us as Waterjet people, we want to make that sound highly sophisticated and complicated, but when we try and break the process down so that everybody understands it, you have to understand that really what we're doing is the abrasive media that we're using is the same media that you would find on common everyday sandpaper, that good hard sandpaper that lasts a long time. So that velocity of that water comes in, it now accelerates that abrasive media, and through proprietary nozzles we can direct that abrasive media to our cut path. And we really are doing high-speed sanding. We're eroding away that piece of material with simply garnet, the same material you find on sandpaper, and sanding our way through it. The water helps to accelerate that media and also to keep the surface cool so that there's no heat affected zone at that point. Abrasive water jets are used in the energy industry. If any of you have had a hip implant or a knee implant, more than likely that titanium root or product was roughed out with the abrasive water jet process before it went to final precision machining. We talked a little bit about food processing here a few minutes ago, cold food pasteurization, but also water can be utilized to slice the cherry in half for the cherry pie that you get at your local fast food restaurant, or when you open that can of or that jar of cherry jam and you see that those cherries are in nice half sections. You go, well, how did that happen? Well, it was probably trimmed with a water jet. One of the things that water jet does in the food processing industry, it allows us to cut with a clean cutting knife every time. So that water stream that's going through there, it doesn't have any bacteria that may have been from a spoiled piece of fruit that may have been preceded, like you would with a cutting blade. When a cutting blade cuts a spoiled piece of fruit, it gets smeared on the next so many pieces until the material is actually cleaned away. This can affect shelf life. Water jet products may have 2 to 3 times the shelf life of products cut with conventional knives and blades and that type of thing. If you go to a restaurant, more than likely your You get a chicken breast. That chicken breast was proportioned. It was cut to size because all chickens don't grow the same size, but yet in the foods industry, portion size is what determines profitability. So with ultra-high pressure water, we can trim those chicken breasts on the fly, and what's left on the sides, that becomes chicken fingers that we pay so much for in our local pub. So there's many, many more applications that Waterjet can be utilized for. The biggest thing for most people is beginning with the right machine, identifying your application. So when we look at traditional XY systems, the biggest question to answer becomes, what's the largest sheet of material that you want to load to this system? So if I want to be able to process a 30-inch by 30-inch piece of material, then a small work envelope machine may work fine for me. However, if I want to be able to process more parts at a time, I can look at a larger workbed. I can cut multiple parts from one sheet of material, or I can process multiple sheets of material at a time. And then also, the next thing to consider is, are all my cuts normal to the world? Normal to the world is typically what we would call 3-axis cutting, X and Y and Z. Then we also offer, as the industry, we offer the ability to bevel or roll that nozzle and remain normal to the surface throughout the cutting process. Those are what you would call 5-axis applications that require an X, Y, Z, and a coordinated CA movement to process that piece of material. Selecting the right pump really comes back to the application again. Again, what is it that you're trying to cut? What's the material? What's the thickness? And then again, how many of these do we want to cut or produce on a daily basis? So we have small horsepower pumps that can process single nozzles, or we have larger pumps that will allow us to process with a larger orifice or possible multiple orifices. So we build direct drive pumps, we build intensifier pump, and then we build extreme intensifier pumps. Selecting the right pump goes back again to determining that application. What is the material? What is the thickness? If I'm cutting at 3/4 of an inch or less, I can probably process that piece of material with what's called a 10-30 nozzle combination. So with a 10,000ths water focusing orifice in combination with a 30,000ths abrasive nozzle, I can accelerate about 0.6 pounds a minute with 60,000 psi water at my peak efficiency. So when we look at that and you go, well, I'm a small shop, I really just need to make one part at a time, a 30 horsepower pump may be just fine for you to be able to power one 10-30 nozzle combination. However, if I'm looking at abrasive Waterjet and I'm now trying to produce more parts, I may need to look at running multiple heads. So as an example, with a 50 horsepower intensifier pump, I produce sufficient water to power two 10-30 nozzle combinations. Or I can do 4 10-30s with a 100 horsepower pump, or 6 10-30s with a 150 horsepower pump. What that does is allows me to increase the productivity out of that single machine tool by processing or producing more than one part at a time. Conversely, if we start and we look at it and we say, gee, I really need to increase my throughput, or I want to cut greater than 3/4 of an inch, I would recommend looking at a 50 horsepower nozzle combination, something like a 15-40 combination, 15,000ths diameter water focusing orifice, which allows 1 gallon of water per minute to escape through it at 60,000 psi, and passing into a 45 thousandths abrasive nozzle. This is probably the most common nozzle used by most of the high production shops in production today. They can accelerate about 1.2 to 1.3 pounds a minute of abrasive. And they will be able to produce or cut that same material faster. So with my 10-30 nozzle combination, I could cut half-inch thick material, and let's call it half-inch aluminum, at maximum separation cut speed at about 24 inches a minute. When we start saying maximum separation cut speed, and we say, okay, what does that mean? Maximum separation cut speed with an abrasive water jet is the definition of making 2 halves of a piece of material. So with my 10-30 nozzle combination, I'm going to remove approximately 30 thousandths of an inch wide kerf at the entrance point of that stream, and I'm going to break out at my bottom side at somewhere around 18 to 20 thousandths. So I'm going to have approximately 10 thousandths of taper, or somewhere in that 5 to 10 thousandths of taper per side in that piece of material. As we begin slowing the process down, again, keep in mind, we're doing high-speed sanding here. I allow it to sand those side walls longer and square up that surface of that cut. So at a speed of approximately 10 inches a minute, now I've squared up the sides in my cut on that piece of material. On the other hand, going back and saying what happens when I go from the 10-30 nozzle combination to the 15-45 nozzle combination, I'm now able to make maximum separation cut speed on that same piece of material at about 40 inches a minute. Substantial increase in speed. In doing so, I'm utilizing more garnet. But typically when we analyze it and we look at just the consumable cost to operate that nozzle, the increased speed will actually result in a somewhat lower cost per inch of cut because of the increased speed. Now the newest technology that we've introduced, the extreme pump with the 90,000 psi, allows us to increase our operating pressure from 60,000 continuous pounds of pressure to a 90,000 pound deadhead pressure, or 75,000 continuous pounds of pressure. And if I take that same energy, now all of a sudden it takes 50 horsepower of energy to power my 10-30 nozzle combination at the 75,000 psi. I can accelerate that same, or just slightly more, say 0.7 pounds a minute of garnet, and now I'm able to cut at almost the same speed as I was able to with my 50 horsepower 1540 nozzle at 1.3 pounds a minute. But I've reduced my garnet usage by 0.6 pounds a minute. Well, 0.6 pounds a minute times 60 minutes to an hour puts us at, somebody else have to help me with the math here, but we're at about 36 pounds of garnet in an hour's time that I can save, and at an average garnet price can be upward of 40 cents a pound for garnet. So now all of a sudden I could save $12 and produce almost the same cut speed as I did with the higher amount of garnet. Now with that comes some increased maintenance because of the higher pressure at operating the pumps. So the question that we have to answer is, what materials are you cutting? What thickness are you cutting? What are your throughput requirements? Are you cutting with straight water? Are you doing abrasive water jet cutting? If we answer those things, now all of a sudden we can begin to start sizing the system. Test cuts. Most every manufacturer will give you the ability or offer the ability to do test cuts. And these are extremely important for understanding the process and doing your cost justification for waterjet cutting. Determining the right system and the right pump to buy. So we look at loaves of bread here as an example. You know, it takes very little energy, very low volume of water. We want to use as low a volume of water as we possibly can because we want to minimize any wetting that occurs to that perishable product as we're cutting it. Then on the other hand, we look over at the aluminum product here, and we look at going through that, and we say, well, how can I increase my productivity and that type of thing. So as you can see there, we have our Q5 and our Q2 and different cuts that we made on that piece of material with different orifice and nozzle combinations. If you're a shop that runs a wide variety of material, I would recommend that you look at a minimum of a 50 horsepower per nozzle setup that you want to operate on your system, because that's what's going to give you your absolute lowest hourly operating cost. When we look at it and we say, can I produce these parts with a single head, or do I need to have multiple heads to process that piece of material? And really it comes down to what's it take to make the throughput requirement. As an example, it takes about $37.50 in consumable costs to run a 1540 nozzle combination at 55 or 60,000 psi on an hourly basis. So if I have a $50 an hour overhead cost and I have a $50 an hour machinery payment, and that's assuming that, you know, financing $175,000 to $180,000 and paying it over 5 years, and I'm only billing 70 hours a month off of the system, then I'm looking at about a $50 an hour machinery payment. Well, that's $137 an hour that it takes to turn that nozzle on. So it doesn't matter what I'm cutting, it costs the same. What changes is the speed at which I can process that piece of material. So we process that half-inch piece of aluminum at 40 inches a minute. If I was processing half-inch thick stainless steel, it would be more like 13 inches a minute. So with that, we have to price our work accordingly. Now, on the other hand, I go out and I say, well, I can't make my throughput requirements at 13 inches a minute. I need to produce 26. I add a second head. But the nice thing about that is that now I have the ability to prorate my G&A costs across 2 heads. I don't have to burden that single head with $50. Now I can burden it with $25. And conversely, if I had 4 heads, I could burden it with $12.50. So with that, when you look at probably the most successful job shops in the country, most of them run multiple head machines. It gives them the ability to make a profit when a person with a single head machine is simply breaking even. Choosing the proper pump. With my EcoJet direct drive pump, 30 horsepower pump, I can actually power a 1540 nozzle combination. The same thing that requires 50 horsepower of energy to do with an intensifier pump. There's some trade-offs here. The direct drive pump costs approximately $20,000 less than an intensifier pump. When I look at it and I go, well, how's the intensifier pump work? Well, the intensifier pump works with an electric motor driving a hydraulic pump. That hydraulic pump drives a double-acting piston lance back and forth that at about 80 strokes a minute. That high-pressure water is driven to attenuator, and it's held until we turn the nozzle on and off. When we look at the direct drive pump, we look at it, and direct drive pumps or piston plunger pumps as they're looked at, you know, that's very similar technology to what you would see in a pressure washer. In the case of our direct drive pumps, we've got an electric motor driving a gearbox, and now we have pistons stroking back and forth at 1,800 strokes a minute. In the intensifier pump, my pistons stroke back and forth at 80 strokes a minute. As you can see, common sense tells you that I'm going to have more wear and tear on the direct drive pump because it's stroking through the seals at a higher rate of speed than I am with the intensifier pump. So intensifiers pumps are lower cost to operate over the long run than direct drive pumps, but direct drive pumps are lower capital cost to purchase up front. They're both fine pumps. They're both extremely proven technology for cutting your material. It's just one gives you the ability to do it with a lower long-term maintenance cost. So again, back to it, more maintenance, shorter life on our components with the direct drive, economical to purchase, and energy efficient. Took a 30 horsepower electric motor to power my 1540 nozzle combination versus a 50 horsepower electric motor to do it with my intensifier pump. Now, when we break it down and we go, well, what's that mean as far as my hourly operational costs? It doesn't make a tremendous difference in that $37 an hour. Maybe I saved $2 an hour in electricity by running a 30 horse versus a 50 horse. And again, that depends on whether you're 460 or 230 volt power. Intensifier pumps, on the other hand, have the reliable tie rod design. With the reliable tie rod design, it's easy to service. We have less maintenance. We have greater longevity. And we really recommend those for people that are going to run a pump 30 to 40 hours a week. They're going to find that they're spending less time and lower maintenance costs in maintaining the kits, the seals, and that type of thing are much lower in cost than they are for the direct drive pump. So initially, though, it's a higher investment to purchase up front, approximately $20,000 more for a 50 horsepower intensifier pump over a 30 horsepower direct drive pump. Extreme pressure, again, gives us the ability to power things to run to higher pressures. And the softer the material, we look at aluminum, we can get almost 50% increase in speed on thinner gauges of aluminum than we can with 60,000 psi. And because of the fact that the single biggest consumable costs, and let's go back, I'll review back to that 1545 nozzle combination. When we look at that $37 an hour, about $23 to $24 an hour of that operational cost was the abrasive media itself at 1.2 to 1.3 pounds a minute. So we come up and we say, what's that going to do when I can accelerate it faster? I'm using the same amount of abrasive, and it means that I have a lower cost per inch, but now it takes 100 horsepower to accelerate that 1.2 to 1.3 pounds a minute. So when we look at it, we have our 1545 nozzle combination. It cuts half-inch aluminum at 40 inches a minute, maximum separation cut speed. When we look at our 1030, 50 horsepower of electric energy, reduced abrasive utilization, I'm just slightly lower, maybe at 39.5 inches a minute for maximum separation cut speed. And if I go up to the 100 horsepower pump, now all of a sudden in that half-inch thick piece of material, I'm almost 70 inches a minute for that maximum separation cut speed. So we as salespeople, we as working with our customers, we'll try and help you select the right pump for you. Do you want to cut single parts? Do you need to produce large volumes of parts, and that we can set that pump to do that, or size your pump to do that. Productivity, multiple heads. We briefed on it earlier, what it means from a consumable cost and producing more parts at lower cost by having the ability to produce or prorate my overhead costs and process them at the same speed with more parts per cut produced. I'm not cutting it any faster, I'm just producing more parts in that cut. Productivity options. To help you increase the productivity of your system, we now offer things such as air drills, height sensors, and laser plate mapping, where we can actually go out and map and load that surface. You know, plates aren't really flat when we get them from that metal service center, so we want to go out and take a topographical map so that we can put that into our control and in turn make very accurate cuts, maintain a consistent standoff of the abrasive nozzle from the part. Most people don't realize it, but if you put the abrasive nozzle directly on that piece of material, it's not going to cut. We need a slight air gap there. We also have things called lights out monitoring. When you're cutting something that's 6 inches thick and it's cutting at an extremely slow feed rate, you'd rather be able to have that operator doing multitasking. So with lights out monitoring, we have the ability to monitor the pressure coming into the cutting head, the abrasive flow rate coming into the cutting head, and as long as we are flowing water at the right pressure and flowing abrasive, there's a pretty good possibility that we're cutting accurate parts. So with that, and by monitoring those things, we can put that into the control so that the operator doesn't have to be standing over that machine watching it. He can be deburring parts, he can be packaging materials to customers, he can be performing other functions. Again, in combination with the height sensor, reliably we can go out and operate that system without having to stand there and monitor it. Everybody's looking for ways to increase productivity and increase value. Many of the parts that we cut with the abrasive Waterjet have to be welded. Well, with the introduction of our 5-axis head, now we have the ability to go in and bevel those parts, a weld prep. Now when I'm coming in and putting that fillet weld, I can take the part, it's ready to go to welding. If somebody doesn't have to hit that edge with a grinder, and bevel that so that I can go in and fill in with my weld. Many products, such as the anti-ballistic panels that protect so many of our soldiers, do not pierce well with abrasive Waterjet. Even with our low-pressure water pierce, we have the ability to lower the pressure in the pierce and gently peck our way through. Many of these composites want to delaminate. They don't like that impact. That's what they're designed to stop. Abrasive Waterjet's like impacting that surface with a shotgun blast. So we developed the air drill to allow products that are fragile to have a hole pecked in them with a drill. And now we're always cutting from an edge. We don't delaminate the part. We don't have any chipping, breaking, those type of things. So again, many of these options are there to help you enhance your productivity. We have mirroring capabilities and nesting capabilities. Getting the most out of that piece of material can be accomplished with nesting. And we offer different varieties of the nesting. If you're cutting large ODs and IDs, maybe some of your smaller parts will fit within them. Increasing productivity through mirroring. We can power 2 Z-axes, and in pulping discs used in the paper industry, in many instances we can actually cut the opposite with the second head that we're cutting with the first. So these pulping discs require as many as 3,500 holes to be placed in them. Well, now all of a sudden we can reduce that time by 40 to 50% by utilizing the mirror function and cutting in both directions at the same time on a common XY system. One of the biggest things is getting the abrasive out of the tank. We offer automated garnet removal systems. If you have to shut your system down to remove the garnet from it, now all of a sudden you've lost production. So with automated garnet removal systems, we can automatically get that garnet out of the tank, deposit it in a dewatering waste hopper, and make it so it's easy to get rid of. Now all of a sudden, I don't have to shut the system down to send my operators in there to dig out the river bottom. And that's really what it's like. It's after a flood trying to dig out the river bottom in an abrasive water jet tank. We also offer closed-loop systems. Closed-loop systems for people who do not have drains in their facility give us the ability to eliminate the dumping of water. So therefore, it's a green system. It works in combination with a chiller that cools the hydraulic system or the cooling on the direct drive pump and cools the water. The water escapes from our nozzle at 140 degrees. So we have to pull that heat back out. We treat the water, pull the trace minerals and metals out of that water, and now it's good enough to go back. It's filtered down to 0.25 micron and can go right back through our pump. Or selecting and maintaining the right orifice. There's many orifices out there. There's sapphires, there's rubies, there's diamonds, but if I have to stop to replace an orifice, now all of a sudden that's lost production, or maybe I even scrapped a part. So we offer diamond orifices that give us the ability to run for extended periods of time. The increased stream quality that we get out of it make the nozzles last longer. The stream stays coherent for a longer period of time as it comes into our focusing nozzle. Therefore, it doesn't wear out the nozzle as fast. Garnet, and again I'm running a little behind here and trying to catch up, but there's many different grades of garnet. There's crushed garnet, there's alluvial grades of garnet. If I'm cutting 6-inch thick material, I might want to hit that just like I would with a very aggressive grinding disc. I might want to hit that with 50 mesh abrasive. That 50 mesh abrasive is going to eat it away just like the guy went out there with his DA sander and a grinding disc on it, and boy, he took it off really fast, but it left a rougher edge. On the other hand, if I'm cutting thin gauges of material, 1/8 inch and under, I may want to use 100 or 120 mesh. Now it's going to look a very smooth surface, very accurate part. So utilizing the proper garnet can reduce the additional operations that I have to go through in possibly finishing that part. Maybe it's plastic. Maybe it's something that requires additional finishing after it comes off of the water jet. And I may be able to reduce that by utilizing a finer mesh and creating a smoother edge in my cutting process. Typically, the larger grades of garnet are less costly than the finer mesh garnet. It takes less sieving and that type of thing to make them. There's crushed and there's alluvial grade. Very simply, alluvial grade was reclaimed from a riverbed or a dry riverbed. May have happened in the ice ages, but it was still a riverbed. And crushed is actually milled out of hillsides and has to be run through a mechanical device to reduce the particle size to the proper grades that we're using. But the crushed garnet have sharper edges on it and will cut slightly faster than the alluvial grades. If you do not maintain your water system, your water jet system properly, you're going to see that it costs a lot to run that system. So maintaining and keeping everything running to its peak efficiency, number one, fixing the leaks when they occur will keep from eroding a seat or a seal away, and therefore your overall operational costs will be less. Getting proper training for the operator is important. You know, the operator should be able to be trained within a week to run an abrasive water jet. He doesn't have to learn a whole lot about the speed at which the mill is going through. He just basically has to learn how to import files and apply the proper cut path to that. And most companies offer continuous training for operators, continuous training for maintenance, continuous training for them. And so as you're changing operators and adding new people to your operation, training is a highly important thing. Therefore, we're not playing the old game of telephone where it got changed and changed. We're always learning from the source. Therefore, we're applying the proper maintenance techniques and also applying the software properly to get the best possible parts out of the machine for our application. And again, with that, I've kind of breezed through those last items there. Are there any questions that we can answer? Does anyone have anything in specific?
Thank you, Jeff. That was an excellent presentation. We do have about 10 to 15 minutes left for questions if anybody would like to type them into their comment box there on the screen. We do have one question, Jeff, for you. It's a job shop employee here who is running plasma and Waterjet. So, you know, assuming that accuracy and cut quality are not his issue, where do you see the two processes complementing, and where's the overlap, and where do you select Waterjet over plasma based on the material type and the thickness?
Excellent question, and thank you. You know, plasma is going to cut materials much faster for the most part than abrasive Waterjet. When you look at plasma as an example, typically the smallest hole you can pierce with plasma is the same as the thickness of that piece of material. So if your material is ½ inch thick, the smallest hole you're going to be able to put in that piece of material is a ½ inch diameter. On the other hand, with the abrasive Waterjet, I could put 120 thousandths holes in that piece of ½ inch thick material. As a general rule of thumb, I mean, we can pierce and create a pierce point that's going to be smaller, but when we look at articulating our way around it, we need about 10 thousandths more material than the diameter of our abrasive Waterjet for the holes that we're cutting in there. So again, if there's areas of the part that require additional machining, it's possible that a combination of plasma and abrasive Waterjet might give you the best throughput. You may want to be able to abrasive Waterjet small holes and details that require, such as a hole that has to be tapped or threads applied to it, and then plasma cut the outer periphery that doesn't have any requirement for no heat affected zone or require any additional machining. Typically, the materials such as aluminum and stainless and some of the things that may not process as well with the brass and copper and those things with the plasma, those are our forte. Those are what really works well with the abrasive Waterjet. And again, we're not thickness limited, but if you're cutting primarily mild steel and you don't have any, the heat affected zone by the plasma doesn't affect any of your additional processes, the plasma may be your best way to process that piece of material.
Great, thank you. I guess this is referring to nesting of smaller parts on plates. Is there a way to do that without using the tabs so that you don't have to take the time to grind those tabs off after the production run?
Well, typically that would depend upon the thickness of the material. Now, one common practice is to utilize something like a sacrificial material under there, such as Waterjet brick, that helps us to maintain control over those small parts that you may be cutting from inside of the OD of the ID of a larger part. When we do that, though, we've induced an additional consumable into the cost of operating the abrasive water jet. I mean, the abrasive water jet's very aggressive. It wants to eat away everything that's in its path. So most of the time, people will tend to go with tabbing their part so that they can remove that entire plate of material as still a contiguous piece of material, quickly load another sheet, get back to allowing the abrasive water jet to cut while they perform those grinding of those tabs and as a outside of the cutting process. But maintaining them together makes it easy to load and unload that piece of machinery. It may not be the best way to do it for your operation, but anytime that we're cutting small parts that are smaller than the width between 2 or 3 slats of material, we have to do something to control that part. Otherwise, it's going to tip, and you're going to have to send Scuba Bob after the parts in the bottom of the riverbed there.
Mm-hmm. Okay. Can you talk about with direct drive pumps using multiple cutting heads? Is that possible? And can you use different orifice sizes if you are using different cutting heads?
In the direct drive pumps, yes, you can use different orifices. However, because they're a mechanically driven pump, the direct drive pumps are going to produce 1 gallon of water per minute. Now, we use a constant speed motor on our direct drive pump. So if I want to run a 10 thousandths focusing orifice with my 30 horsepower direct drive pump, I have to send the additional water that pump is making to drain. So in the case of running smaller orifices on direct drive pumps, you have to typically dispose of the additional water that you're making. You can't, there's no place for it to go. Otherwise, it would just continue to build pressure, and the pressure relief valve would dispose of that water for you, the additional water. So okay. With that, can you run multiple heads? Yes, you can run 2 1030s, but we really need to match those 2 orifices to the output of the pump. So in the case of 30 horsepower EcoJet direct drive, it generates 1 gallon of water per minute. We would need to operate with 2 1030 nozzle combinations or 10 thousandths orifice combinations if it's a straight water application, or 4 5,000 or 4 7,000 orifices, and that would utilize the full capabilities of the pump and produce no overpressurization problems.
Very good. One of your customers is on here. He runs a Jet Edge 90,000 PSI pump. He's cutting 3/8 inch 4130 using 2 heads at a time. There you go. 10 thousandths orifice and a 030 nozzle. So what would be the optimal garnet rate and cutting speed? And would making the distance between the plate and the nozzle smaller help?
Typically let's start with the first question, typically making the distance between the nozzle and the part smaller. You know, ultimately we want to stand off about 125 thousandths from that piece of material. You can't go any closer or much closer, because when we lose that air gap, for some reason the process stops, and none of our engineers have ever properly explained that why it stops to me. I just know it does. On the other hand, with the 2 1030 nozzles, the proper garnet flow rate would be about 0.7 pounds a minute. Now, depending on whose garnet you're utilizing, I would recommend taking a Dixie cup or something and taking a 30-second shot from our metering valve, basically turning the abrasive valve on for 30 seconds, allow it to go into your Dixie cup, and take it to the postal scale and weigh it, because alluvial grade from one supplier will flow at a different rate than another supplier. and vice versa. As a general rule of thumb, I don't like to recommend much greater than 80 mesh abrasive through a 10-30 nozzle combination. So 80 mesh with a good hard rock garnet at about 0.7 pounds a minute per cutting head is going to get you your maximum. It's going to run you at peak efficiency to get your maximum flow rate and feed rates.
Very good. Jeff, what do you see coming in the future for the needs of industry for waterjet cutting? Seems like this person calls out composites for military applications. Seems to be something that's been getting a lot of attention in the last few years. What do you see coming down the road, in addition to
composites for military applications have been a tremendous user of the technology. All composites process well with, for the most part, with abrasive waterjet, with the exception of some of the Kevlars, and it depends on what the binding agent that's utilized with the Kevlar. If it's a ceramic Kevlar, boy, it gets a nice smooth glass-like edge to it. If it's more of a gummy binding agent used with the Kevlar is pretty tough stuff. It'll leave like with the epoxy Kevlars, you'll get more of a fraying to the Kevlar where it wants to pull before it shears. When we look at it, we're still very much in the growth stages. We're moving into tighter and tighter accuracies. When you look at 5 years ago or 10 years ago, as an industry, plus or minus 15 thousandths of an inch was as tight a tolerance as most shops wanted to quote to. Now with the utilization of our tilt taper heads and the ability to take out taper out of those parts, we're seeing that we can produce tighter tolerance parts. So as people begin adding tilt capabilities, they can now tighten up the tolerance band that they can cut for many parts. But still in quoting materials and quoting cut parts, I stress everyone to look beyond the CAD drawing that you received from your customer or from your design department and make sure that we're producing parts that are fit for function. Just because the automatic dimension feature in our AutoCAD had the ability to dimension a part to 3 decimal points or 4 decimal points, is that really a requirement for producing the part and fit for function in our applications? So we need to dig beyond that, and we need to make sure that our draftsmen and our designers are not calling out tolerances that are more costly to manufacture than they need to be. And therefore we'll get more out of the abrasive waterjet.
Right. Speaking about quoting jobs, there's one of our viewers is quoting a job now with what is this, 15,000 stainless, and he wants to stack the parts, stack the plates, and get multiple parts per cut. His concern is edge roll, since the parts need to be flat. Is that something he might be able to do? Stack 15,000 stainless?
You're probably going to lose the bottom layer, or else have to put some sort of a sacrificial material under it. I would want to run with that 15,000 stainless. I'd probably want to run with 100 or 120 mesh abrasive. But in stacking materials, the nice thing that occurs is that, and let's just take a stack of 8 layers of 15 thousandths thick material. The first 7 layers won't roll the edge to speak of. Normally, the only one that's going to show that roll will be the back surface, or that last part that's there. All the stack above it, each one became a shear surface for the piece of material that was above it. So therefore, It's kind of like even working with a pair of scissors at that point. As we're working our way down through and cutting it, the layers below become a shear surface for the one above. And normally we only see that roll in that back piece of material. Now a lot of people that are cutting what I'll call shim packs will actually take and put a sacrificial material under there, maybe like a hard plastic or something like that that they cut against to help with that shear of that last sheet and to keep it from folding away from or pushing away from the abrasive energy as it's sanding its way through it.
Okay, good. We only have time for maybe one or two more questions. There's a few more on the list here. Let's see. We run our Waterjet all day cutting larger material without using a chiller. When should we use a chiller? Where's the break on that?
You know, the other question would be, do you recycle your water? I mean, tap water will do a good job of cooling that intensifier pump. When you should look at utilizing a chiller and you say that you're running it all day long, if you're running it 8 to 10 hours a day, and let's just say as an example you have a 50 horsepower pump, you are probably utilizing between 5 and 7 gallons of water per minute in cooling that intensifier pump. So we look at it and let's take it on the high side. Let's say 7 gallons. So we're using 420 gallons of water per hour to cool that intensifier pump. And just for my simple mind, I'm going to call it a 10-hour day. So we've used 4,200 gallons on a daily basis in cooling that intensifier pump, not including our cutting water. This is just the cooling circuit itself. So in looking at that, the first thing you want to do is you want to pull out your water bill. And, you know, I visited a customer here recently, and they go, well, we don't get a water bill. It's part of the rent. I go, well, then why would you want to buy a chiller? Until the landlord figures out that, you know, he's paying $7 per thousand for your water, and it's costing him $28 a day for chilling your intensifier because he's supplying the water and doesn't realize it, you may not want to make that investment. But on the other hand, if you're running multiple shifts, now all of a sudden, you know, what's it take? And so for a 50 horsepower intensifier, as an example, it's a $9,000 investment to add a chiller to it. You got to kind of do the math. What's it take to pay that, to make that, or pay for that that chiller in my hours of operation? If I'm recycling my water, again, I want to utilize a chiller because we want that incoming water to be around as cold as we can, under 70 degrees. 70 degrees would be the maximum inlet water pressure. And as I mentioned earlier, when that water escapes through the focusing orifice, before it ever begins any friction work with your material, it's 140 degrees. That's just the action of it passing through that focusing orifice. So we need to take that heat out if we're going to try and recycle the water for cutting. Again, if you're at 100 horse, you may be more than like 10 gallons of water per minute. Now all of a sudden it starts to even more. Now all of a sudden I've got 10 gallons a minute. I got 600 gallons an hour. So I'm using a lot of water at that point in the cooling that can go towards the paying of a chiller.
Right. So here one of the attendees then mentions the fact that he is using a chiller and his water's coming in at 65 degrees, yet he's only getting 140 hours out of his pump seals. What are some of the areas he should be looking to increase his seal life if his water temperature is 65 degrees?
Well, number one we need to look at is calcium and hardness of his water, because look at what's there. You know, let's just say he's at 400 parts per million in hardness and total TDS, total dissolved solids, in his water, and has a lot of turbidity coming from his municipal water source or his well, if he can reduce that to 200 parts per million, he should see approximately a 50% increase in his seal life right there. So making certain that he may need to look at water treatment if he's not currently softening the water. If he is softening the water or running it through a deionization system, he needs to look at his pH on that water. We want to be, and I run into this a lot of times with people that have both EDM and abrasive water jet in their shop. They're going, well, I got a DI system, and so with deionization, the problem is that you can reduce that softness or hardness of the water down into more of a pH of somewhere in the 6.5 or below. That's aggressive water. That will begin to attack some of the stainless steel components that are in your system, and when those begin to roughen up, you'll start to see, again, reduced life in your seals because of that aggression that's in that water at that point. So we want to be neutral in the water. We want it somewhere in that 7 to 7.4 range on pH, and we'd like to be less than 200 parts per million in our TDS level, total dissolved solids.
Very good. All right, one follow-up question, and then I think we're going to wrap this up. Regarding stacking the thin stainless, what's the best way to hold down materials when you stack them like that?
Typically, you're going to have to utilize some sort of clamps, or you know, I even have some customers that will utilize something like particle board on the back side, and they will in the waste area, they may be able to go in with like some drywall type screws and screw some clamp the material down so that we can make sure. Hopefully it's good and flat when you started, and now we just need to maintain it flat. You know, if it's coming off of roll goods and it's holding some of that set to it, again, about the only way I've seen to do it is to possibly go in some of the scrap areas and fasten it with a drywall screw of some sort to that plywood backing.
Very good. Thank you very much, Jeff. Thanks, everyone, for attending today's program. We hope you found it to be a valuable experience. Again, please remember that an archive recording of the program will be available on Metal Forming Magazine's website soon, and you'll find a link to that on our website and on the JetEdge website. We'll email.
Oh, and please visit us at FABTECH.
You bet. See JetEdge at FABTECH, see Metal Forming Magazine at FABTECH. And you'll hear from us soon again with a link to the archived webinar so you can share it with others in your organization, or just review some of the topics that Jeff covered in great detail today. So everyone have a great afternoon, and you may go ahead and close your browsers now.
Thank you for your time.
Thanks, Jeff.